Okay, look at this example. So if I have been asked to sketch a graph of y equals to minus e power of the sum of x plus 2, okay, and plus 5. Okay, the way to do it is to describe the dilation, describe the transformation of this graph from the standard graph y equals to e power of x and sketch it. Okay, let's do it. So, okay, when I look at the equation, I recognize a reflection, okay, because of the minus sign in front of the whole graph. So I will have a reflection on x-axis this time. Okay. After reflection, I need to describe dilation, and in this graph, there's no dilation. There's no the coefficient of x in this graph is 1, and well, I have a minus 1 times e power of x plus 2, so there's basically no dilation. Okay. And now I have to label translation, and there are two translations. There is one translation horizontally from the bracket, well, from the power, okay, and there's a translation vertically at here. So it moved 5 units, translated 5 units up. The horizontal translation, you have to make whatever in the bracket equals to 0, okay, which is minus 2, so it moved 2 units left. Okay. Now let's sketch the graph. Okay. I draw my axis there. X-axis, y-axis, and from the first step, the reflection, I noticed my graph is going to be something like this, because it's reflected on x-axis, and there's no dilation. Also, it moved 5 units up, means the asymptote, actually the whole thing here, moved 5 units up, okay, and 2 units to the left. So my asymptote is going to be y equals to 5, and the graph looks like something like this. Okay, and now I can label it as y equals to minus e power of the sum of x plus 2 plus 5. Okay, from the graph we can say there is a one y-intercept and one x-intercept. So let's find them. So we have to make x equal to 0 for y-intercepts. So y will be minus e power of 0 plus 2, okay, plus 5, and we have 5 minus e power of 2, which is your y-intercept. So we label it 5 minus e power of 2. Okay, and okay, and now we have to check the x-intercept, which is we have to make y equals to 0, and let's substitute it into the equation. I will have 0 equals to minus e power of x plus 2, okay, plus 5. And then we can rearrange this equation, and we will have e power of x plus 2 equals to 5 minus equals to 5. Okay. Now we have to solve this equation to give us x-intercepts. Okay, the idea to do it okay, the idea is to do it. We have to use I have to introduce something called log. Okay. When we want to find a power, well, sorry, in an equation, when the power is unknown and we want to find it, we have to use log. Okay, and log, well, to simplify it, log is to find power. Okay, and let me show you how do we do that. Okay, okay, let me open my calculator first. Okay, in your calculator, you will have your power. You will have a key called log. Okay, you will have key called log and ln code. Well, they are the same thing. Okay, I'll show you in a minute the difference between them. So what's happened is, in say if I have 2 power of x equals to 10. Okay, what I have to do is I have to use log. So the power x equals to log 10 and the base 2. Okay, we put the base there as a small number. Okay, we move the base to here, okay, to us just after the log, and we just copy down 10 inside the log. Okay, okay, and for instance, for the questions there, e power of x plus 2, e power of the sum of x plus 5 plus 2, okay, equals to 5. When I rearrange it in this form, I will have x plus 2 equals to log 5 base e. Okay. Always remember the base is the small number there, the other number just copy it down. Okay, and x is going to be log base e 5 minus 2. Okay, in your calculator there are 2 logs. As you can see, we have a log here, and I have a ln. Okay, the log button in your calculator is equals to log base 10, and the ln button in your calculator is log base e, and you only have these 2 logs, 2 bases of log in your calculator. So if we want to solve this, I can I have to use ln. So in your calculator, just type ln 5 minus 2, which is, let's say, ln ln5 minus 2. Sorry, ln5 bracket, okay, minus 2, which is a minus number, minus something. Okay, so in the questions above there, well, our graph is going to be, okay, after we find out the number, our graph is going to be something like that. Okay, that's, we can label it as ln5 minus 2. Okay, we can just label it as ln5 minus 2, and in this case is 5 minus e power of 2. This should be, well, a minus number. Okay. Okay, this should be our graph. So, okay, this, okay, this is basically log. When you want to find some power, we use log. Okay, and okay. 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 But in calculator, we only have 10 base and e base. Okay, so log base 10 or log base e. So if I have something like x equals to log base 2 10, I can't solve it directly using our calculator. We have to convert it in the form of log 10 and log e. Okay, the idea to do it is simple. So I introduce some formulas now. If I have log base a b, okay, it will be log say log base e b divided by log a e base e. Okay, you can use base 10 too, but as long as the base of the log is the same, we can convert it this way. For instance, it can also be log base 2b divided by log a base 2. Okay, we can convert a log in this form. Okay, also so when we have this formula, we can easily solve this question. X is going to be, say, log 10 base e divided by log 2 base e, which is, using our calculator, I will have log e. Okay. Log e 10. Okay, log base e 10 divided by log base e 2. It is going to be 3 point something, 3.32. Okay, if I put this value back to power of 3.32, I will have approximately 10. Okay, let's try it. 2 power of 3.32 will be 9.9. Yeah, approximately 10. Okay, so this is your first formula.